series, sigma rotation exam style question. In this question we're given a summation from the first term to the kth term, and the rule is 2 times 3 to the power of r, and that is equal to 59,046. And we want to show that k is equal to a certain value. So, like most series questions, it is worth writing out the information and then calculating the first few terms. So when r is 1, 2 times 3 to the 1 gives us 6. The second term, 2 times 3 squared, well 3 squared is 9, times 2 is 18. The next term, 3 cubed. 3 cubed is 27, times 2 is 54. And we could keep going to the kth term. However, hopefully you've spotted that this is a geometric series, and the first term is 6, and the common ratio, well, 18 divided by 6 is 3. I'm confirming that 54 divided by 18 is also 3. We know that the sum of a geometric series is a times the common ratio to the power of n minus 1 all over the common ratio minus 1. So the sum of the first k terms is equal to 6 times 3 to the power of k minus 1 over 3 minus 1, and that is equal to 59,046. So let's tidy that up. Well, in the numerator we have 6, denominator 3 minus 1 is 2, 6 divided by 3 is 3. Now the next step is we could divide both sides by 3, which gives us 19682. Adding 1 to both sides, 19683. Now, to solve this exponent, we need to use logs. I'm going to use log base 10. And remembering, log 3 to the power of k can be written as k log 3. And as is to show that question, we want to make sure we show each step. Finally, k is equal to log of 19,683, all divided by log 3. And we have shown our answer for part A. In part B, we now want to find, using this value of k, well, doing this calculation, k is 9, and we want to show that, calculate for k plus 1 to 13, and we're using the same rule. So just always check you're using the same rule. Okay, so let's write that down beneath. So for part B, well, from the previous part, we can use our calculator to find that k is equal to 9, which means our question is, let's just check, from r equals k plus 1, so k plus 1 is 10, up to 13, and the rule is the same as before, 2 times 3 to the power of r. Now we have two options here. We know it's a geometric, so we could use the geometric summation formula. However, we're only looking for 4 terms. So we could actually, in this question, just write out those terms. So 2 times 3 to the 10 plus 2 times 3 to the 11, 2 times 3 to the 12 plus 2 times 3 to the 13, which gives us a total of 4,723,920. Now, had you wanted to do the summation formula, we would need to have done the following. To find from the 10th term to the 13th term, we would need to have found the sum from the first term to the 13th, and from that we would need to have subtracted the sum of from the first term to the 9th term, which would have left the 10th, 11th, 12th and 13th. Now in this case that would be more work, but just because it was only a short number of terms we needed to find out. So it's worth bearing that in mind, that that bit in blue would be more useful if we had to find more than 4 terms.